Algebra 2, section 4-6. The quadratic formula. And the discriminant. The quadratic formula and the discriminant. So the quadratic formula here is x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And where do all these letters come from? They come from this form of a quadratic, ax squared plus bx plus c. So that's where all those letters come from. All right, so let's do an example. I've got x squared plus 5x plus 6 equals 0. Now, let's say I don't know how to factor this. I don't remember how to say I add two numbers together to get 5, and those same two numbers, when I multiply them together, I get 6. And I forget that, and I'm like, I don't know what to do. But somehow, I forget that, but I remember how to use this formula here. So, here's what we do. This is A, so that's a 1 right there. Here's B, and here is C. And so we just plug these numbers into the formula. X equals negative b, that's 5, plus or minus the square root of b, again, squared, minus 4 times a, which is 1, times c, which is 6, all over 2 times a, which is 1. Now, we're gonna go through this here and simplify this. Before we do, though, here is the biggest. This is the part where I see the most mistakes right here. I've got minus 4 times 1 times 6. Oftentimes, there's a negative number here. And when that happens, many people forget to multiply the negative times the negative to be a positive. Or if I have two negatives here, then that should end up being a negative. Negative times negative times negative is negative. So paying attention to those negative and positive in this section, that's where I see the most mistakes probably in using the quadratic formula. All right, let's move on. Negative 5 plus or minus the square root of 5 squared is 25. 4 times 1 times 6 is 24, all over 2. Now I've got 25 minus 24 is 1. And the square root of 1 is 1. So I have negative 5 plus or minus 1 over 2. Now, this is plus or minus, so I've got to set this up into two different guys here. So x equals negative 5 minus 1 over 2, and x equals negative 5 plus 1 over 2. Negative 5 minus 1 is negative 6. Negative 6 divided by 2 is negative 3. Negative 5 plus 1 is negative 4. Negative 4 divided by 2 is negative 2. All right, let's do another one. X squared plus 6x plus, equals 16. All right, so I need to subtract 16 from both sides so that I can get my correct c value. X squared minus 6x plus 6x minus 16 equals 0. All right, now from this point on, I want you to do the rest of this using the quadratic formula. All right, go ahead and pause and go. Okay, let's see how you did. X equals b, which is 6, plus or minus the square root, negative b. Yikes, don't forget the negative, that's important. Negative b plus or minus the square root of b squared minus 4 times a times c, which is negative 16, all over 2 times a, which is 1. All right, now let's start simplifying here. 6 plus or minus the square root of, I'm just going to do all of this work inside here and put it right there. So that's 36. Negative and negative, I'm going to end up with a positive. 4 times 16. 4 times 16 is 64. And so that gives me 100. So I've got 6 plus or minus the square root of 100 all over 2. Now, square root of 100 is 10. So I've got x equals 6 plus 10 over 2, and x equals negative 6 minus 10 over 2. So x equals negative 6 plus 10 is positive 4 over 2 is 2. And negative 6 minus 10 is negative 16. Negative 16 divided by 2 is negative 8. There's my solution set. Okay, now, looks like, oh yeah, that's right. Okay. Now, let's go ahead and look at this next section here. We have one rational root. Now, a quadratic, this is another term, or when we graph a quadratic equation, we get a parabola. So in this instance, we would have a parabola. Notice how we set this expression equal to 0. So we would have a parabola that looked something like this, where it went through 2 and negative 8. What we're finding is the roots. See how we have it equal to 0? So whenever y is 0, we find what x is, and those are our roots, or our solutions. Now, when we have one rational root, we're going to have a parabola that just hits the x-axis at one point. It might be here, it might be over here, whatever. And so we're going to have one rational root. Let's see what that looks like. X squared plus 8x plus 16 equals 0. Okay. Now, we could plug this into, let's just plug it into the quadratic formula, even though you might be able to look at this and know how to factor it. We're going to use a quadratic formula so that we can continue practicing it. X equals negative b, which is 8, plus or minus the square root of 8 squared minus 4 times a times c, all over 2 times a, which is, again, 2 times 1. A lot of times we got 1 for a, right? Now, let's get through all of this mess. 8 squared is 64, minus, so there's only, these are positive, so I don't have to change that subtraction sign, minus 4 times 16, which we know already is 64. We did that one just a moment ago. So in here I've got 0. X equals negative 8 plus or minus the square root of 0, which is just 0, over 2. So now I end up with x plus or minus 0, so that just goes away. Negative 8 over 2 is negative 4. So I end up with just one root. When in here I have 0, I'm just going to end up with one root. Whatever's inside the radical, if that becomes 0, then I end up with something plus or minus 0 over 2. I end up with just one root. And so for this one, my graph would look something like this. It would just hit the graph at -4 and go back up the other direction. Also, my axis of symmetry would be at -4. There's x equals -4, right? Because it is a line. X equals -4. Okay. Let's keep moving here. Now, you might also come across something that has irrational roots. So I've got 2x squared plus 6x minus 7 equals 0. All right. So let's use the quadratic formula. That's what we're doing. So this particular equation here, we couldn't even use the magic x on it, and you'll see why here in a second. Like if we were to try to use the magic x, we wouldn't be able to solve it. We have to use the quadratic equation. So, or formula, I should say. B squared, negative b squared. Oh gosh, what am I? I've already lost it. All right, negative b plus or minus the square root of b squared minus 4 times a, which is 2, times c, which is -7, all over 2 times a. Whew. Okay, x equals -6 plus or minus, let's do all of this mess inside here. X squared is 36 minus, but see we have a negative here, so that's going to end up being plus. All right, I'll take care of the signs right there. 4 times 2 is 8. 8 times 7 is 56. 36 plus 56 is 92. So square root of 92 over 2 times 2, which is 4. Okay, I'm going to look at the square root of 92. So this is almost our answer. We're almost done with this. There's not much we can do left here. So I'm going to say 2 times, 46? And 2 times 23, and there's nothing I can do with 23. That's a prime number. So, but I can pull this 2 out here. So I've got x equals -6 plus or minus 2 times the square root of 23 all over 4. Now I can see each of these terms has a 2 in it. So I'm going to factor out a 2 from this, and I'll be done. X equals -3 plus or minus the square root of 23 over 2, and we will leave it like that. That is an acceptable answer. I would take that. All right, so that is irrational roots. Notice if I take the square root of this, I'm going to get an irrational number. Complex roots, we're going to look at that. Once we're done looking at complex roots, we're just going to do one example, and then we're going to look at what the discriminant is, and that will be the end of this lesson. We're going to do one example of complex roots. X squared minus 6x plus 10 equals 0. Going to use my quadratic formula. X equals -b, so I've got -6 here. I'm gonna write it out, -6, just to make sure that I took care of this negative here. Plus or minus the square root of -6 squared minus 4 times a, which is 1, times c, which is 10. All over 2 times 1. All right, I'm going to write x equals -6 is going to give me +6, plus or minus, and then I'm going to work on what's inside of here. -6 times -6 is 36. Minus, this is all positive, so I'm going to keep the minus. 4 times 10, which is 40. 36 minus 40 is -4. And so I have x plus or minus the square root of -4 over 2. Okay, so now I can erase all of that line there. I can simplify this -4 here. So remember, this is -1 times 2 times 2. So I'm going to take all of that out. When I take the square root of -1, I get I. So x equals 6 plus or minus 2i. 2i over 2. Now each of these has a 2 in it. So I am going to say x equals 3 plus or minus I, not over 2 because I divided 2 out from everything. So 3 plus or minus I. That's it. All right. Now what this looks like as a parabola is it looks something like this. Notice how it doesn't cross the x-axis at all. All right. And here we are for our last little bit. We're not going to do any more examples. We're just going to fill out a little chart. And we're going to learn a little bit about the discriminant. The discriminant is b squared minus 4ac. Notice this is what is inside the radical of the quadratic formula. The discriminant is what we put inside the radical of the quadratic formula. And what this tells us is what kind of roots we have. We use the discriminant to find out what type of roots we're going to find. So if I have b squared minus 4ac greater than 0, so if my discriminant is greater than 0 and is a perfect square, then I know I have two real rational roots. Now, if b squared minus 4ac is greater than 0 and it's not a perfect square, so let's look at an example of this first one, or the first examples that we did, where the discriminant became 1, which is a perfect square. The discriminant here was 100, which is a perfect square. And so we saw real rational roots. All right, so that's this section. Now, if it's not a perfect square, which is what we saw here, then we ended up with two real irrational numbers. Roots, irrational roots. Now, if we have, our parabola would look something like this, or it would look something like this. Now, so we have two roots for each of those. Now, what if our discriminant resulted equal to 0? We did have one that did that, right? Back here, we had here, when the discriminant was 0, then we ended up with one root. So if the discriminant equals 0, then we have one real rational root. And the parabola is going to look something like this. Oops, it's going to hit, there we go. It's going to hit the graph there. It could be like this as well, either one, doesn't matter. It's going to hit the x-axis at one point and then turn back the other direction. And the last outcome of the discriminant would be if b squared minus 4ac is less than 0. And that's the last one that we looked at here, the complex roots. Notice how I have -4 as my discriminant. So if it's negative, then I'm going to end up with 2 complex roots, meaning I'm going to have an I involved. I'm going to have a number plus or minus a number multiplied by I or something like that. I'm going to have an I involved, and it's going to look something like this, or something like this. The parabola will not cross the x-axis. And that is the end of section 4-6.